Topic 5.1, Introduction to Soil Systems. So we've outlined in the first part of this course the various factors involved in sustainability. And now we're going to look in more detail at three different areas. One, of course, would be the oceans, the lakes, water. We call that the hydrosphere. Another one would be the atmosphere, air, and the gases in there, greenhouse gases. And the third that we're going to look at in more detail is what's going on in the soil, or the ground, which we would call a lithosphere. Most people don't think much about it, but there's actually a lot of life going on in that portion of the earth. So let's just take a look in general about what is soil. Soil actually takes a long time to be produced. It's really a combination of organic material and mineral material. If you look at a cross-section of soil, it's really divided into 6, sometimes people consider 5 different areas. They're called horizons. Starting from the top, they're labeled O, A, E, B, C, and R. Sometimes different textbooks use different abbreviations for this. What we want to be concerned with is that the top portion here is the organic. So this material is actually being ground or decomposed down from the O into the A horizon. And therefore we get a mixed mineral content there. Where was that mineral coming from? It was really coming from the E horizon, which we call the alluvial or leached. Leached means water is running through it, and it's moving it up here. So really the E horizon is moving mineral content up, and the O horizon is really moving organic down. And then it's put here and put under pressure, and this is really where soil is beginning to form. As we go deeper down here, we get into what people like to call bedrock and so forth. Much more solid material, not being ground down or being ground down extremely slow. Subsoil would be down below it. And if you've ever heard contractors talk, they typically talk about building up a proper subsoil. You can see when this doesn't happen appropriately, houses start leaning, we get foundations failing. What's the function of soil? Very complex things go on in soil, and it really depends on what the constituents of soil are. Well, the obvious thing, of course, is it's a medium for plant growth. Although we've seen with hydroponics that plants don't necessarily need soil. Sometimes plants need it just for anchorage. But normally, plants need soil because it's a medium in which minerals and water and air are transferred to the plants. So that's how they get nutrients. A lot of life actually goes on in soil, microorganisms, not just worms and so forth, but bacteria, fungi, and so forth. And this is really necessary. I remember once watching a science fiction movie and life on the planet was dying, and they discovered, looking at the soil samples, that the reason why life was dying was that actually all the microorganisms had died within the soil, and that's where it started. And the obvious thing, too, is that soil contains water, and it transfers water, and there's a very delicate balance, as we'll see in a moment, between transferring water and storing water. I said before that soil formation is extremely slow. It takes a lot of conditions to come together. We're going to move those two horizons together, minerals coming up and organic matter coming down there. Organic matter pretty much comes from leaf litter and soil erosion. So if you remember the Gershmel diagrams that we did before, litter contains a lot of the material that's ground up on top of soil. And then we have to move it all together, and the way we do that, of course, is with movement of water. Movement of water can be called leaching or transpiration. And once these two come together, minerals and organic material from the two different horizons, we then get a chemical transformation or decomposition. We call this humus. We can also have a slower mix in there from weathering, from rocks. We talked about this in our first semester when we talked about sulfur and phosphorus cycles. So one purpose is anchorage for roots, and we see this a lot in areas where we have mudslides. The soil has been eroded and it's lost its proper mix. therefore plants don't hold. In particular, in northwest areas, a lot of coniferous trees don't have very good anchorage. They tend to grow in poor soil conditions, and we see a lot of pine trees leaning over. But you also have to have a structure that allows the movement of water, oxygen, and minerals, and the storage of them at the same time. And that's kind of an interesting idea. So, for example, with water, you want water to be able to move through soil, but you don't want it to move too fast, then you get a mudslide. So there's a balance there. Another interesting thing about soil is that it's really considered to be almost like a sink, in that it is a stable environment. So the temperature doesn't change all that much. Typically, you may see that animals like to live underground. It's a very stable, constant temperature area to live in. And also the pH doesn't change all that much. As we'll discover later on, the pH can be very important in growth. So in Oregon, for example, where we are, the pH is slightly on the acidic side, which causes some problems. We don't have great soil for agriculture up here. So what does make soil good for agriculture? Well, first of all, there are 3 different particles that make up soil: sand, silt, and clay. They are based on the size. Sand is the biggest particle, then silt, and clay is extremely small particles. And you can put it together here in a triangle, what's called a soil texture triangle. There are the 3 percentages on the side there. And if you look at what the constituents are, you can decide what sort of soil it is. So, for example, suppose I had a soil which was, 70% clay, and then 20% sand, and that leaves 10%. There's the 10% over here. So we would say that that sort of soil would be classified simply as clay. What are the properties? Well, the 3 different particles, because of their size, give us different properties. And it's very, very simple. The bigger the particle, the easier things move through it. The smaller the particle, the easier they store things. So, for example, clay, very, very small particles. We would assume water does not move easily through it, and that instead clay tends to hold water. It's pretty impermeable. Sand would be the opposite. Sand is very, very good at filtering things. If you take a cup of sand and run water through it, all the water pretty much goes through, and it takes out a lot of the, impure, dirty parts of it. Air would be the same way. Air is necessary for plants, so if you had a clay soil, very difficult for air to move through it. If you had a sandy soil, very easily for air to move through it. But remember, we also want to store a little bit, so that's important too. Let's go back to water. You might say, okay, sand is great. Water moves very easily through it. Yes, it does, but it also doesn't store water very well too. So that would be bad for plants. And if you've ever been on the ocean and you see the tide come in, the minute the water hits it, it just gets drained right down through the sand, and the sand becomes dry again. So not good long term. What you can see, we really want to have a soil type which is a blend in between of the 3 types. Primary production. Remember, primary production means autotrophs at the photosynthetic level, plants and so forth. What are the factors that these guys would want? Well, they would want to grow in a soil that has lots of minerals, that has fairly good drainage. They wouldn't want to be waterlogged. At the same time, they would want it to contain some water. They would want air to be available, and most importantly, they would want access to organic material. So, sand would probably be low, clay would probably be low, and this type of soil is what we call loam. Loam is considered to be the perfect soil, and if you even look at it right up there, it just looks good, right? Don't eat it, but it looks good. And sometimes you have seen these movies where farmers will actually take a pinch of soil, taste it, and they go, that's the right stuff. What is the perfect combination loam? 40-40-20. 40% sand, 40% silt, 20% clay. And so when you go to the gardening store and you buy a bag of topsoil or some sort of potting soil, that's probably loam. And that concludes our introduction to soil.